My name is Michael Smart, and I work in research and development at Jadu. And I've got about 3 minutes to talk to you all about AI.
Not really.
So our focus right now is natural language processing through artificially intelligent services. Okay, and we're going deeper than that, and we're starting out with something that we're calling sentiment analysis. So natural language processing, to give a little bit of a background, it's been going on for years and years. I don't know if anyone can cast their minds back to a slightly darker time when they used to make us book cinema tickets over the phone, but it was awful. And to demonstrate how far we've come in the last few years, if you take a look at things like Apple's Siri, Amazon Alexa, or Google Assistant, it's a much more natural part and integrated into our everyday lives. This has come about down to something that we're calling low-cost computing. So from a monetary and computational standpoint now, technology, although it may not always seem like it, is in the best place it's ever been. It's more efficient and it's cheaper today than it's ever been in history. So before we do a deep dive, and we're going to go into a very brief workflow of how we're training machines at Jadu, I thought I'll give you an overview of what we're actually setting out to achieve. So we are setting out to teach machines to recognize patterns by example rather than programming specific rules. This ties into directly what Suraj was saying with the uprising of low tech. So traditionally, our software, we take data in, and then we as programmers, we write rules and conditions to do things with that data and then serve it on the front end in a very simplified way of how basically all of our software works. With machine learning, we're not doing that. We're letting the machine write that logic, create its own rules. We're giving it examples of what we want, training it, and then releasing it out into the world. So at a very high level, here's some natural language that we're feeding into our machine, and it's returning a probability that the text is positive or negative. So in this context, we're calling these features. So we have two features of positive and negative, right? And we're not limited to these, but we're starting out with them. It seems easier right now to start on the polarizing end of the spectrum, as that's about as least ambiguous as we can get with natural language. But we can definitely see applications of adding more features, things like detecting threat or vulnerability in natural language. So let's move on to the actual training. Now, as humans, we can only make accurate predictions from the things that we know. Well, the same extends directly to machines. So for this next part, let's imagine our machine as maybe a young toddler or a brand new puppy, right? It's got some skills available to it, but we're not really ready to release it yet. We don't want it making any independent decisions like driving our cars or anything like that, right? We need to teach it the absolutes that we know as humans. In our human example, this might be the difference between hot and cold. Our puppy example, eat the sofa, don't eat the sofa. And in our machine, it's the difference between positive and negative, right? We're giving it a knowledge base so it can make informed decisions down the line in situations that it's never been in before. So here's a very simplified example of how some training material might look. I have a set of examples here of natural language, half of which are positive and half which are negative. I then go through, as a human, and assign a sentiment to them manually. I'm declaring my expectations to the machine and letting it know exactly what is negative and what is positive. Now, training is iterative. And to further exhaust the toddler-puppy machine metaphor, it's not enough to simply tell our puppy not to eat the sofa 3 or 4 times, right? We need to do this thousands of times. Well, in the case of our machine, this might be as many as 1 million times. So I have my example training graph here. So if we imagine we're inside the machine's brain, okay? And I've conveniently plotted this graph in 2 dimensions. In reality, this is going to exist over many dimensions. In the case of image recognition, where we're looking at RGB values of individual pixels with high levels of categorization, this could be graphs with millions of dimensions, which is pretty tricky for our minds to comprehend. But for our machines, luckily, that's just fairly trivial scaled mathematics. So our machine has a best guess. We've fed it in our training material, and it's now trying to plot a line on to separate the two and detect our features. So in this example, anything above the blue line is positive sentiment, and anything below is negative. So you can see after 100 iterations, it's fairly basic at this point, right? So we perform more iterations. We start to see the graph mold. And in machine learning, this is called fitting to our training data. Now, the way it does this is it makes predictions against our training material and then compares them to the examples that we gave them as humans. If it's correct or if it's incorrect, it slightly adjusts its graph to the training data. 10,000 iterations, we can see that we're starting to take shape. And at 100,000 iterations, we can see that our machine has really now started to fit to our data. So we might be at a point here where we want to evaluate this on some information that it's never seen before. Now, this 100,000 figure is not set in stone. Machine learning right now is as much of an art as it is a science. There's no exact time when to stop training, and there's no exact amount of training data that we need to feed it right now. We need to be aware of a phenomenon called overfitting, and we see this out in products today, where machines are too well trained. This graph line is too fit around its training material, which means that it doesn't perform as well out in the real world. It's too good at the things that it's seen, but it's not very good at things that it's never seen before. So let's move on to how at Jadu we're solving this, and how in research and development we're starting to bring these machines to life. So if we take a very quick trip back to this slide, as you can see, I went through each of my 6 training examples and gave it a manual label as a human. That was fairly easy, took me about 3 minutes to do. This isn't going to be enough. If we want to release our machines out in the wild, we want to give it more of a base of knowledge than just these 6 examples of natural language. We may need as many as 50,000 extracts to get started. Now again, this isn't an exact science, but that's a ballpark figure to even get off the floor. So as you can see, going through and manually labeling each one of these examples of natural language is out of the scope of one human being's work. And I'm not just saying that because at Jadu, that human being would be me. But we want to keep our training data as unbiased and accurate as possible. So this means we need a collective human engagement in order to build this training data. We want to represent everybody's feelings on sentiment, not just mine. So this brings us on to my first demo of the day, and this is Miyagi. Now, Miyagi is an open source, in-house toolbox developed at Jadu in order to create, aggregate, and crowdsource this training material. So I'm just going to jump out of my slideshow for a second here and jump into Miyagi. Can we all see that? Let me just scale him up a little bit. So picture the scene. You're a Jadu employee. You arrive to the office. You get a parking space, no problem. You go and grab your coffee, and you sit down, right? We mark all our emails as read, and then we log into Miyagi. This is how we're building these sets of training data. Miyagi serves us with an extract, an example of natural language. In this case, good morning, thank you for assisting my query so promptly, have a great day. Then as a human, I'm giving some labels to this data, okay? So it's some suggestions that I need to give it. So in this case, I'm going to say that's positive. Here we go. This is not good enough. We wait far too long for our bins collected. Everyone on something street hasn't had their bins collected this year. Now you can see an example of Miyagi at work here, and that he's redacting personal information. We want to remove anything from these training material that doesn't affect the sentiment and keep everything anonymous, as we don't feel that that really impacts sentiment, like names and numbers, that sort of thing. I think it's safe to say that that one's negative. Please find and attach my passport, blank, blank, blank. Okay, that's neutral. Okay, so that's enough of Miyagi. This is how we're approaching machine learning at Jadu. These are the building blocks and how we create these huge contextually rich data sets in which we can feed into machines to release them out into the wild. So what's next? Well, we want to take Miyagi, which currently just exists at Jadu, and we want to put him right inside our software. We want to put him directly on the CXM timeline and empower our customers to create their own intelligent digital services. So for my last quick live demo, I'm going to jump over to Jadu support. Now, some of you may recognize this. This is our very own account of CXM that we use every day at Jadu, and it's how we manage our support queries. So I'm in my timeline here. Let me just zoom in a tad. Okay, so I can see my new messages, and in the top right corner of each entry, we can see some question marks, right? So our machine right now is in its learning phase. It's not actually deriving sentiment from natural text, because we're not at that point yet. We're in that first really important stage of creating rich contextual data sets in order to allow it to make informed decisions in the future. So as a CXM user, I can go over to the side here, and let's just have a little read here. So my bins have not been collected this week. It's becoming a huge sort of stress for me and my family. Can we look into a matter of urgency? So as a human, I go in, and I let Miyagi know the sentiment of that message. This is my opinion on how that message is coming across as a human. So we'll just go up again, and we've got David's response here. Good morning, John. Thanks for getting in touch. I'm really sorry to hear. Okay, that's nice empathy. Direct response from Dave. I see that's positive. And we've got a response here, okay. I think that's certainly neutral. Okay, and David, have John, I've spoken to our collections department. We arranged to visit probably today. Yep, very direct from David there. And last one, thank you very much for the prompt response. The collection teams arrived today, and were very pleasant. I'm happy for this case to be closed. All right, great. All's well that ends well. We turned it around for John today. These are the building blocks to this automation. This is the very start and the early level of machine learning. This is the not so glamorous side that you often don't get sold, right? So as humans, we need to go in and start building these rich contextual data sets from which our machines can then use and learn. Because if we buy products out on the market today, they've likely been trained on standard generic data sets, right? So they've seen a lot of natural language, but not necessarily in the context that we need them to see. And we know how broad of a subject that can be. So by using this intelligent textual analysis and the research that we're doing into image recognition, we're really excited at Jadu and in research and development on where these technologies are going. We're hoping to create frictionless, seamless user journeys. And we're hoping that over time, that our machines will see less question marks on our timelines, and we'll start to see sentiment tagged right there in real time as messages come in. Close up, we can see a benefit of having that information in front of us, but if we take a step back, reporting across thousands of case types, millions of customers, we can really see where the power of analyzing sentiment of certain areas of our business come into play. We can start to identify where things are going right, where things are going wrong, and where we can jump in and assist. I think I've almost certainly run out of time now. So thank you very much for listening, guys. You've been great, and that's all from me. Thank you.